secant passes through the circle, and secant intersects the circle at two distinct points. It just has to cross through the circle. It doesn't have to be through the center, it just has to intersect twice. Now, that's one secant. Now, if you have two secants, right? And if those two secants intersect in the interior of a circle, all right, then you form a couple of angles. So here you have two secants and they intersect in the interior of a circle. Does it say that they have to intersect in the center of the circle? No. They just have to intersect inside the circle. And how many angles do you form when you do that? Four, right? But basically, if you have angle 1, then you have a vertical angle that's the same as angle 1. And if you have angle 2, you have that vertical angle that's the same as that. The measure of an angle, like angle 1, let's say, is 1/2 the sum of the measure of the arcs intercepted. Okay? What does that mean? So let's just take a look at angle 1. This is angle 1. If you look at angle 1, the arc that it intercepts is which arc? AB. Now, angle 1's vertical angle intercepts which arc? DC. Okay? The measure of angle 1 is half the measure of those two arcs. So it's half of the measure of AB plus measure of DC. Arc DC. Okay? Yeah.
Could also just be like half 2AB.
No. Because they're not necessarily the same. Those two arcs are not the same. Why? Because the point of intersection is not at the center. So the ends do not have to intercept equal arcs. If we what do you call it? Exaggerate a little bit more. Suppose the intersection is here. Now you've got angle 1 here. Look at the arc intercepted there and look at the arc intercepted there. You see how they're not the same? Only if it was a central angle would those two arcs be the same. Yeah?
But isn't it that the measure of the arc is the same as the measure of the angle?
Of a central angle. This is what I'm saying. This is not a central angle. So the center of the circle might be somewhere there. This is not a central angle. So there is no way of knowing how big each one individually is without having some more information. All right. So then if you look at measure of angle 2, right, that's going to be half of the measures of which two arcs? Right. AD plus measure of arc BC. Okay. All right. So moving on. Look at this one. You need to find measure of angle 2. Now, BC is 30 and AD is 20. Always mark your diagram. Like this one has been marked for you, but make sure that you always mark the diagram. All right. We need to find measure of angle 2. These two arcs can be used to find which angle? 1, right? So let's find measure of angle 1 first. Measure of angle 1 is half of what plus what? 20 plus 30. So measure of angle 1 is equal to 25. All right? Now, if this is measure of angle 1, what do 1 and 2 add up to together? 180. Therefore, measure of angle 2 is 180 minus 25. How much? 155. Well, because it's a linear pair, right? Think back to chapter 1 and 2. It's a linear pair. All right. Now, here, yeah.
If we didn't know it was a linear pair, you found angle 1.
You have two secants, right? Two secants that are intersecting where? Where? Inside the circle, right? Two secants intersecting inside the circle. Now look at this one. In this case, we have a secant. Now, a secant is a line. It's supposed to go through, but in order to, make this diagram simpler, They just cut it off here. But this is a secant, right? Because it crosses the circle twice. Now, what is this line at the bottom? That's a tangent. So here you have the intersection of a secant and a tangent. And where is that point of intersection? It's on the circle, right? Not inside, it's on the circle. So that's what you have to remember. You've got a secant and a tangent, and they intersect on the circle. Can they have intersected anywhere else, really? I mean, right, it wouldn't matter, right, if they intersected outside. All right, so if a secant then and a tangent intersect at the point of tangency, then the measure of each angle is 1/2 of its intercepted arc. What does all that mean? Well, it means this. If you've got angle 1 here, that angle is formed by the intersection of the secant and the tangent. That angle measures 1/2 of the intercepted arc. What's the intercepted arc here? Arc AB, right. So measure of angle, this should say measure of angle 1. Measure of angle 1 then is 1/2 of the measure of arc AB. Okay? And here, that should say measure of angle 2. How much is measure of angle 2 then? It's 1/2 of which arc? ACB or not ABC. It's BCA, right. So it's 1/2 of the measure of arc ACB. Okay? That's a major arc. How many letters does it get? 3. Okay. Here's an example. We need to find measure of angle ABC, this one, if arc AB measures 102 degrees. Okay? So what do you think? How do we do this? Yeah.
So since, can you extend the tangent BC?
You can. Do we need to? Do we want to?
It's easier to see.
What else can we do? What else can we do? How big is this arc? Since we want to find that angle, let's look at that arc. Right. That's 360 minus 102, which is how big? 258. So now the measure of the angle that I want, measure of angle ABC, is what?
1/2 258.
1/2 of 258, which is how long? How big? 129 degrees. Right? Questions? Okay. Now we've got a whole bunch of other situations. Okay? So we saw an intersection of two secants. We saw an intersection of a secant and a tangent. Now let's look at all the other combinations. In the first example, what two shapes are intersecting? You have two what here? Two secants. You have two secants intersecting here. Here you have two what? Here what's intersect? A secant and a tangent, and here two tangents. So you have two secants, a secant and a tangent, and two tangents. There is one thing that all three have in common though, and that is the location of the point of intersection. Where do all three cases intersect? Outside the circle, okay? So we had one case, the first one, where the intersection was inside. Then we had the intersection was on the circle. Now the intersection is outside the circle. So if you have, these combinations that intersect in the exterior of a circle, then the measure of the angle is 1/2 the positive difference of the measures of the two intercepted arcs. It's a mouthful, okay? The positive difference of the measures of the intercepted arcs. What does that mean? All right? So basically what I want to find is the measure of this angle, right? Now, by these intersections, how many arcs have been intercepted? 2. You have 2 arcs intercepted, right? There is always going to be a bigger arc and a smaller arc. Okay? And you want to subtract big minus small because you want to get a positive value. That's what that means, the positive difference. So the big arc minus the little arc. So in this case, it's going to be half, measure of angle A is equal to 1/2 of arc DE minus BC. All right. Yeah. It'll always be apparent. It will.
Well, for the one like right under it, it's not very apparent.
So, hang on. So I always say the measure of the angle is equal to half of the big arc minus the little arc. All right, and if you say that, I don't know, it just somehow like just sounds better. So the measure of the angle is half of the big arc minus the little arc. Look at this one. Okay, you've got again two arcs that have been intercepted. One is this, okay, and the other one is the blue one, BC. So this is going to be half of, what's the big arc? DC, measure of arc DC, minus measure of arc BC. So always say this, the angle is equal to half of the big arc minus the little arc. The angle is equal to half of the big arc minus the little arc. Because sometimes you're looking for the little arc, sometimes you're looking for the angle, and it always helps when you just say it out loud that way. You can't say it out loud during a test though. All right, in this case, it's half of, where's the big arc here? Right, it's going to be the outer one. Half of, what is it? What's the name of the arc? BDC minus measure of BC. Okay? All right, so let's do an example here. We need to find the value of x. I always say it out loud in my head as I'm writing it, right? The angle is equal to half the big arc minus the little arc. You don't have to write it down each time, but just say it, right? So what's the angle here? X is equal to half of, what's the big arc? 120 minus 50. So X is equal to half of 70, which means it's 35. Okay? Now, I'm going to give you a minute to do part B, okay? And we'll return in a minute. All right, so X is equal to 20. Right, so the angle, so look, the angle, always say it, the angle is equal to half of, so the angle, which is X, is equal to half of the big arc or the outer arc minus the little arc or the inner arc, okay? And then you will simplify, substitute the half, x equals 3x minus 40, and then you solve for x, and x equals 20, okay? All right, let's do C, and we'll get back to Liam in a minute, and somebody else could put it on the board. All right, C, we'll be back. X is 235 for this one. And the angle is half of the big arc minus the little arc, which is 360 minus x. So 110, and so on. All right. Last one. Find D. Find x for part D. Okay? So, did you finish?
Yeah.
Okay, let me see. All right. So this is part D. Go ahead and do part D. Yes. All right. So in this case, we're going to first find this part. So from 360, we subtract 148 and then 128, and we get that that's 84. So the angle is equal to half of 128 minus 84, and then x equals 22. Okay? So what we need to do is x is equal to half of this arc minus this arc.
I know, but like when you found, like, I don't know where you got the 118 from.
There is no on 118.
There is no 118. Where?
It's on freeze.
Oh, it's 148.
It's on freeze.
Oh.
It's still right.
It says freeze, but it's not on freeze. It's weird. I don't know what's going on.
Oh.
I don't know. Okay. So that's the answer. X is equal to 22. Now, this homework, is there more? Oh, there's more. Well, this one is, so this one is a summary of everything we learned in this lesson. So basically, you can have intersections on the circle. You can have intersections inside the circle, and you can have intersections outside the circle. That's how these are classified, okay? And based on each one of them, you then have to just, keep track of how are you going to find that angle of intersection, okay? All right, this homework is going to be due tomorrow. Right. Tomorrow we'll cover section 7, and Wednesday we will review. Okay?